Okay, Trig students, we're done with Chapter 5, and as I promised, this is a video reviewing the main ideas that you'll need to know to be successful on the test. All right, so up on the board for your entertainment, I have all of the formulas that you will have to memorize and put into a formula sheet before you start the main part of the test. So you might want to quiz yourself, maybe make some flashcards, whatever it is. You need to know those formulas. Once you turn that sheet in, I will go ahead and give you the correct formulas so you know you're doing it right. Okay, so let's start out the types of problems. I'm really tired of these types of problems, and I know you probably are too, because we seem to have done so many of them. But it's going to start out by saying angle A is in quadrant 1, the sine of A is 3/5, and then it's going to say find. Okay, these are just problems that you will use all of these properties to find those. And so the best I can say is get that quiz out that we took, practice those. Remember, the quiz did not cover the half angles, so you want to make sure that you get those included. Yes, it's just the half angles that are missing on the quiz. All right, so I'm going to move on and talk more about what else you need to do. So here we go. The proofs. There will be 3 of them. Okay, 3 proofs. Look at the proof packet. Try some of those proofs over again. Don't forget the all-important conjugate. That's going to help you out. And just to keep you on your toes, there'll be a new proof like this one. What makes it a new proof is that it's going to use the double angles, the half angles, and maybe even a sum or difference. Okay, so here's an example of one. You're going to prove the sine of 2x times the cosecant of x is equal to 2 cosine x. All right, so we're going to start on the left side. It looks a little bit more complicated than the right side. The sine of 2x, that's easy enough. We replace that with 2 sine x cosine x using the sine 2x formula. The cosecant of x is 1 over the sine x, right? You can see what's going to happen here. I have a sine in the numerator, a sine in the denominator, and easy as pie, the answer is 2 cosine x. Okay, so make sure that you're able to bring together proofs and properties, and you'll be okay. All right, another type of question that's a little bit new. Remember, we have done problems like this a lot, where we simplify using the sum and difference formulas to simplify cosine of 360 degrees minus x. What's going to be different on the test is that instead of in degrees, the question will be in radians, all right? But the procedure is the same. You're going to use the sine difference formula, which goes sine 2 pi cosine x minus cosine 2 pi sine x. And just like always, one of them will go to 0, and I hope you see that it's the sine of 2 pi that's 0. So 0 times cosine x is gone. Cosine of 2 pi is 1 times the sine of x, right? And so the answer, simplified, is the opposite of the sine of x. Okay, there'll be just one of those on there. And then because you love them, there'll be some thinking questions. So here are examples of thinking questions. I might tell you that angle A is in quadrant 3, and you have to ask yourself, where would 2A be? So this is the procedure we use in class. If you're in quadrant 3, then that means A is between 270, 180 degrees, right? So 2A, and I get from A to 2A by doubling, is going to be from 360 to 540. All right, so we remember that once around the circle is 360, so here would be 450, and this is 540. So the best you could say is that if you're in quadrant 3 and you double the angle, you're going to be either in quadrant 1 or quadrant 2. Does that make sense? Likewise with A over 2, if A is in quadrant 3, then when we get this inequality, instead of doubling the 180 and 270, we're going to cut them in half. I think you should be able to do those pretty well. There'll be 2 questions like the following. This is from section 5.5, where I just give you this, and you'll be tempted to raise your hand and say, oh, I forget what they're asking here, Mrs. Stipe. But no, you won't, because you're going to practice. So you remember in class me saying that when I write this, I need you to draw a picture of an angle that has a sine of 3/5. So you immediately call this angle A and draw this picture. Likewise, this is going to be angle B, and you're going to draw an angle in standard position where the cosine is √3 over 2. Okay, so 3 squared, 4 squared, this would be 1, right? We remember that that's an exact value. All right, so now I'm asking you to find the tangent of A plus B. All right, so I'm going to go ahead and write tan A plus tan B over 1 minus tan A tan B. Okay, and I haven't actually finished this problem. I'll let you go ahead and do that. Remember, tan A, we're going to get from this triangle, is 3/4, and tan B is 1 over √3. And you can go ahead and simplify that, and then by the time class comes, I'll have that worked out. Okay, another one like that only has one angle, and we'll call this angle A, and we're trying to find the cosine of 2A. And so you immediately draw a picture where that's not the sine. Here's the sine is 1/5, and so then this would be √24 or 2√6, right? And so I want the cosine of 2 times that angle, and we know that that's cosine squared A minus sine squared A, so you would simply do √24 over 5 squared minus 1 over 5 squared, and you would get 23 over 25, okay? So check that out and make sure you can do that. There'll also be a question that is similar to a proof, and we've done a problem like this in class, where I'm giving you something that's not an identity. I'm telling you 5 times the cosine of A is not equal to the cosine of 5A. And I just want you to give me a counterexample. And all that means is give me an example that makes this statement false. All right? And so truly, you can pick any angle that you're familiar with. All right? So let's go ahead and try 30 degrees. All right? So 5 times the cosine of 30 is equal to 5 times √3 over 2. All right? But the cosine of 5 times 30 is the cosine of 150, which is negative √3 over 2. All right? And you are done. That's all you need to show. Okay, and then the last thing I'm going to show you is another application of sums and differences of angles. And so we have values that we know exact values of. So for instance, we know the sine of 30 is equal to 1/2. We know that the cosine of, let's say, 45 is equal to 1 over √2. Okay? But there are many, many values that we do not have exact values for. So let's say I wanted to know the sine of a 15-degree angle. All right? And so without a calculator, I say I don't know. But if you can write 15 as the sum or difference of angles you know exact values of, so do you agree 15 is the same as 45 minus 30, right? Then you can go ahead and find this using a sine difference formula. So we're going to say sine 45 cosine 30 minus cosine 45 sine 30. All right, so here we go. Sine of 45 is 1 over √2. Cosine of 30 is √3 over 2 minus 1 over √2 times 1/2. Okay, so we're just going to, oops, a little too far. We're going to put this together, and we get √3 over 2 √2 minus 1 over √2 √2. And so final answer, √3 minus 1 over 2 √2. Okay, so because of these sum and difference angles, we are able to find exact values for angles we didn't know before. Okay, if you can do all of those problems, if you can do the problems from your quiz, the proof packet, and any other worksheets, you should be in good shape for class. See you in class.